This is a supplement to the Algebra Lesson 1.1 for CalcPath Geometry. We're going to do a couple brief examples to clarify solving with fractions for those of you who are at home who need a quick review or may have been confused as you were watching today. So let me minimize this and maximize this. So we had two types of problems that we looked at today. One was like this and the other was like this. Now, these are not from your notes. These are other ones that I pulled or made up real quick. What I want you to notice is that there is a key difference between these two. On the problem on the left, the only fraction that we see is the fraction that's connected to the x. So if there is only one fraction and it is multiplied by the variable, we can follow our usual steps of distributing, combining like terms, getting the variable to one side, undoing addition and subtraction, and undoing multiplication and division with one mild change. And that is when we go to get rid of the 2/3, we need to multiply by the reciprocal. We reviewed today what the reciprocal was in class. For example, a fraction like 3/4 has a reciprocal of 4/3. So those are reciprocals. So we'll review that. So if you see a problem like those, which most of your homework problems that involve fractions are like this, you'll be able to use this approach. On tomorrow's worksheet, you'll have more problems involved that are like this. So we want to talk about that. And this particular problem on the left, or on the right-hand side, we're looking at fractions on multiple terms. This term has a denominator, that term has a denominator, neither one of those is a denominator of 1. This expression right here has a denominator. Now, most of you today preferred to split this up into two fractions and look at it as 2x over 6 plus 3 over 6. And the reason that you chose to do that is you wanted to think about it as, I want to clear the denominator, and to do that when you have multiple fractions in an equation. And this only works if it's an equation. If we're simplifying, if we had a problem like this, we would have to get these to have the same denominator by converting these fractions, and then we would put them together as we were able to. But because there's an equal sign, when we have multiple fractions, we can use the least common denominator to clear the denominators. And in class, we said that we would do this by multiplying every term. And for some of you, it was easier just to multiply the numerator, because that is what we're multiplying. Multiply every term by the least common denominator and reduce it. And we'll look at why that works mathematically in a second. So let's go back to this one. This one has just a fraction on the variable. So we're going to solve it just like all the other problems we do. We're just going to pretend there's a number in front of x and that it's being multiplied by x. So there's no distributing, no combining like terms. The variable is already on one side. We need to undo addition and subtraction. We undo addition by subtracting 7 from both sides. This gives us 2/3 x equals 3. To undo multiplication of a fraction, we are supposed to multiply by the reciprocal. So we're going to multiply both sides of the equation by the reciprocal. So right here we have 3 over 3 becoming 1, 2 over 2 becoming 1, leaving us 1x, or just x on the left-hand side of the equation. Because 3 goes into 3 one time, 2 goes into 2 once. On this side, I have 3 over 1 times 3 over 2. Some of you will choose to multiply and then divide. Some of you will try to simplify. This one doesn't simplify if you're looking at numerators and denominators. So 3 times 3 is 9, 1 times 2 is 2. This is 9 halves. X equals 9 halves. 9 halves can't be reduced, so that is our answer. To check our answer, we plug it back into the equation. 2/3 times x plus 7 equals 10. Our answer for x was 9 halves. So we're going to put that in, and we should see that this side over here does reduce to 10. 2 goes into 2 twice, so those cancel. 3 goes into itself once, and 3 goes into 9 3 times. So what that makes is that makes all of this 3, and 3 plus 7 is 10. So you could do it this way. You can also plug it into the calculator if you're just doing a quick check, as long as you showed how you plugged it in to verify that you had the correct answer. X equals 9 halves is the correct answer. Again, when there's only one fraction and it's multiplied by the variable, we're going to get that by itself. That's why we got rid of the plus 7. And then we're going to multiply by the reciprocal value of that fraction on both sides to get x by itself. Over here, we have the multiple fractions. I can't just worry about what's on x because I have fractions and I have more x's in this, not just one. I'm actually going to have to get some like terms together. So most of you today said, let's split this up. This is 2x over 6 plus 3 over 6. They're just taking one fraction and splitting it into two separate terms. The least common denominator of 2, 3, and 6, or the least common multiple of 2, 2, 4, 6, 8. Hey, we got 6, I don't need to worry. Of 3, 3, 6. And of 6, 6, 12. The least common multiple is 6. So the least common denominator is 6. What we're going to do with that 6 is multiply every single term. Mathematically, what we're doing is we're saying, hey, we know the least common denominator is 6, and we don't want any denominators anymore. So we're going to really multiply both sides of this equation by 6. And in doing so, the equation is still balanced because as long as whatever I do to the left side of the equation, I do the same thing on the right, the equation is still balanced. So I'm going to multiply the 6 by both of these terms. So this will give me 6x over 2 minus 6 over 3. Now, some people reduce it as they go, but a lot of you found it easier just to distribute it to the numerator, because this is 6 over 1. So 1 times 2 is 2, 1 times 3 is 3 for the denominator still. And over here, same thing. 6 over 1 times 2x over 6 gives you 12x over 6. And 6 over 1 times 3 over 6. 6 times 3 is 18. 1 times 6 is 6. You're saying, well, Mr. Ritter, they're still fractions. And they don't have the same denominator, so I can't really combine them. But I don't want to combine them. I'm trying to eliminate the denominators to make the equation easier to solve. What we've effectively done is we can now reduce these fractions. 2 goes into 6 3 times, so this becomes 3x. 3 goes into 6 twice, so this becomes 2. 6 goes into 12 twice, so that becomes 2x, and 6 into 18 3 times. So we've taken an equation that had fractions with different denominators. Instead of converting them to all having the same denominators and working with the fractions, which is one way that, at least in first hour, we talked about you could solve it that way, we make the equation simpler. We no longer have to think about fractions because we have taken the least common denominator and multiplied both sides of the equation by it, or every single term in the equation was multiplied by the least common denominator. When we reduced those new fractions, the denominators are all 1. So now it's a matter of getting your variable to one side. Subtract 2x from both to get that. I have x minus 2 equals 3. And then undoing the operations around x, undoing addition and subtraction first, using inverse operations. The inverse operation of subtraction of 2 is adding 2 to both sides. We have x equals 5. I can take my 5 and put it back into the original equation before I even separated it. The original equation was x over 2 minus 1/3 equals 2 times x plus 3 all over 6. And x, we said, is 5. So it's 5/2 minus 1/3. And if you want, you can convert your fractions. They'll both have 6th. Or you can use the calculator to do a quick check since you're going to be doing multiple problems. On this side, I get 2.16 repeated, which is 2 1/6. On this side, I have 10 plus 3, which is 13/6. And 13/6, uh-oh, we have a slight problem. Let me see what happened here. Plus 2. 3 plus 2 is 5. That should work. Oh, I'm sorry. 13/6. I plugged it in my calculator wrong and said we had a slight problem. We don't. 13/6 is the same decimal value, 2.16. So 2 1/6. 6 goes into 12 2 times, so 2 1/6. So since both sides turn out to be the same, x equals 5 is our answer. So once again, if it has just the variable on x, you're going to get that part by itself and then multiply by the reciprocal. If it has multiple denominators, split it into individual fractions, find the least common denominator, and distribute that least common denominator to every term, to the numerator of every single term. Once you've done that, simplify your fractions, and you should have a much easier equation to solve. Stay tuned if you'd like to see an additional example of each of these problems. Here are some additional examples of what we just did. So here is 7 minus 5/2 x equals 10. In this particular problem, the only fraction that I see, or the only denominator that's bigger than 1, is the negative 5/2, and that is on the variable x. Because of that, I'm going to approach this problem by getting this by itself and then multiplying by the reciprocal. To get rid of the positive 7, I'm going to use the additive inverse, which is negative 7. I'm going to subtract 7 from both sides. So now I have negative 5/2 x equals 10 minus 7 is 3. To undo this fraction, this multiplication of negative 5/2, I'm going to multiply the left side by the reciprocal, 2 over negative 5. In effect, the 2's will divide out. 2 over 2 is 1. Negative 5 over negative 5 is 1. I'll be left with 1x. Whatever I do to the left side, I also have to do to the right side. So I will multiply that also by 2 over negative 5. This will give me 6 over negative 5, which can't be reduced. And that is my answer for x. X equals negative 6/5. I can check my answer by plugging it back in. 7 minus 5/2 times negative 6/5 equals 10. I can either multiply these, or I can simplify this by saying 2 goes into 6 3 times. If you choose to multiply them, you'll have 5 times 6 is 30. 2 times 5 is 10. You'll get 30 over 10, which is 3. And 7, and it was negative times negative, which made that a positive 3, which does add to 10. The way that I was simplifying it was 2 goes into 6 3 times, so I've got a negative 3 there. 5 goes into 5 once, so I have minus a negative 3. 7 minus a negative 3 is 7 plus 3. An additional example where there are multiple fractions. X over 4 minus 1/6 equals 4x minus 5 all over 12. In this case, my denominators are 4, 6, and 12. And before I start this problem, since I know that there's not just a multiplied fraction on x, that there are multiple denominators and multiple fractions in the problem, I know that I'm going to use the least common denominator. The least common denominator of those three fractions is 12, because 4 will multiply to 12. One of the multiples of 4 is 12. One of the multiples of 6 is 12. So the lowest common denominator will be 12. Now, rather than convert these and say, multiply this by 3 so I can have 3x over 12, I don't want to convert them. I want to eliminate the denominators. Before I can do that, most of you preferred to separate this into two fractions. You don't have to. If you're not going to, then you have to at least put your numerator in parentheses so that when you're done, whatever number's left up here will get distributed into both terms. Most of you wanted to separate it, and that's okay. So if you separate that, you have 4x over 12 minus 5 over 12 on the right-hand side. To each of these fractions, to both sides of this equation, our goal is to eliminate the denominators. So we are going to multiply both sides of the equation by 12. We're going to distribute that 12 in. It's 12 over 1, so really it's being multiplied by the numerators. So this becomes 12x over 4 minus 12 over 6. On the right-hand side, it becomes 48x over 12 minus 60x, or minus 60, not x, just minus 60 over 12. We still have fractions, but that's because we haven't reduced yet. So in class, I tried to do the steps together, but a lot of you struggled a little bit with reducing versus multiplying, so I'm hoping this will help clarify for those of you who were a little confused as you left. 4 goes into 12 3 times, so this becomes 3x. 6 goes into 12 twice. 12 goes into 48 4 times, and 12 goes into 6 5 times. So this is the resulting equation. These expressions are equal, just as these expressions were equal. So we're still going to be able to find the answer for x. Now I'm going to move my variable to one side by subtracting 3x from both sides. This leaves me with negative 2 equals 1x minus 5. To get x by itself, I'm going to add 5 to both sides. This gives me x equals 3. I'm going to take that answer and plug it into my original equation. So I'm going to have 3/4 minus 1/6, which we could now convert to have a common denominator. I'll do that to show you. Or we could do it in the calculator. 4 times 3 minus 5 over 12. On the right-hand side, I have 12 minus 5, which is 7. So I get 7/12 on the right-hand side. On the left-hand side, I need a common denominator of 12. To get those to have a common denominator of 12, I would need, that's their least common denominator, to multiply this one by 3. On top and bottom, that gives me 9/12. I'd have to multiply this one by 2. So that's minus 2/12. 9 minus 2 is 7, so that is 7/12. Hopefully this video helped clarify the steps for you. I know in class, this step in particular may have been confusing because we were doing it simultaneously. We were multiplying and reducing, multiplying and reducing, multiplying and reducing, multiplying and reducing. The video shows you that you can take it as 2 separate steps, which may help you to be more efficient and more successful with it. Have a great day.